We are now practicing area and volume with calculus. So first, you need to know area and volume are integration questions, and then we need to know how to do that integration, what the setup looks like. So we're integrating on these questions. So I want you to look at that first area volume one. You have a graph, two graphs, and one is F and one is G. And they're not telling you exactly which one is which, but I'm going to help you out in a second. Because it's question number 2, you get to use your calculator. So you need Desmos out. So the first thing I actually want you to do is to take Desmos and put these both in Desmos as a step 1 before I start answering it. So I'm going to do that too. So I'm going to write f at x equals, and I'm going to use the restriction for the most part that I see there. So f at x is ln x plus 3. And I'm going to use the restriction, that's what, negative 2? I'm going to use that. Let's try negative 2. And then 1. There I see it. So I see the one on top is the logarithm. The second one, g at x, and that's x to the 4th plus 2x cubed. And again, I'm going to do a restriction here, the same restriction. So I'm going to go negative 2 to 1. All right, so I have them. I see obviously the red or the logarithms on top and the bottom. Top subtract bottom is going to be a constant theme here of what we're going to do. All right, so back here, now we can start answering the questions. So I'm going to move this to the side. So first, find the area of the region enclosed by F and G. So how do we find area? Top subtract bottom, and with the bounds that are on the graph. So I know top, and so the logarithm's on top, the polynomial's on the bottom. I need to know the left and the right bound. So this is going to go from negative 2 to 0.781. So I'm going to do right here. This is from 2022. This is number 2. So we're going to integrate. We just said it's from negative 2 to 0.781. I'm going to round to 0.782, though you don't have to. And I'm going to go top subtract bottom. So I don't have to write out the equations. I can just do what they're labeled. So we have f at x and g at x. They're already defined. So it's just the top, which is f at x, subtract the bottom, which is g at x. And then we actually have to do that in our calculator. So let's do that. So go back to Desmos, type in letters I and T, and then put in from negative 2 to 0.782. And then f at x, which is already defined, so I can just go f at x subtract g at x dx. And I get the answer 3.603. All right, A is done. B. From negative 2 to B, so that's what this is right here. That's B. So we found that already, that decimal out. From negative 2 to B, let h at x be the vertical distance between the graphs of f and g. Is h increasing or decreasing at negative 0.5? So first of all, I'm going to create an equation for the vertical distance. So that's always the top, subtract the bottom. So whatever the point on top is, subtract the point underneath it. That's the vertical distance. I need to do, if I want to know if it's increasing or decreasing, I'm going to take the derivative of that. So that's the derivative of f minus the derivative of x. And then I want to know if that answer is positive or negative at negative 0.5. So then I'm going to plug in negative 0.5 and use the calculator. And if the answer is positive, it's increasing. If the answer is negative, it's decreasing. So I'm going to go back to Desmos. You can press pause if you like. And I'm not going to write v, I'm just going to go f derivative at negative 0.5, subtract g, the derivative, at negative 0.5. Make sure I typed it in right. And I get the answer negative 0.6. Now I get to write a sentence. So when x equals negative 0.5, the vertical distance between f at x and g at x is decreasing at a rate of, and because I said the word decreasing, I won't include the negative, and it's a rate of 0.6. All right, part C. The region enclosed by the graph of f and g is the base of a solid. So this is now going to be a volume question. Cross sections of the solid taken are perpendicular to the x-axis are squares. Find the volume of the solid. So I'm going to remind you, how do we do that with known cross sections? So the basic setup, we're still going to integrate the same numbers. So negative 2 to 0.782. And for known cross sections, we take the area formula. And if I know the area of a square is you take the base and you square it. That's the formula. And the base is going to be top subtract bottom. So I'm going to use both of those to set this up. So I'm going to integrate from negative 2 to 0.782. And then I'm going to go, the base is top subtract bottom. So that's f at x subtract g at x. And the formula is take that base and square it. And then that's what I'm going to type into the calculator. So again, int negative 2 to 0.782. I'm going to do two parentheses here because I'm going to square it. And then close it dx. Oops, move that cursor. Close it dx. And you have the volume. So the volume's 5.340. All right, part D. One more left, and then the question's done. All right, a vertical line in the xy plane travels from left to right along the base of the solid described in part C. The vertical line is moving at a constant rate of 7 units per second. Find the rate of change of the area of the cross section above the vertical line. All right, so for this one, we're just going to look at one cross section, and to find the cross section, the area of that cross section. So we're not going to integrate to find the volume, just that one cross section is going to be top subtract bottom, and we square it. So if I looked at one cross section, what's the area of one cross section? That's what it would look like. Now, I'm going to understand that just as the area. So this whole thing is just like the area of that cross section. So when I take the derivative here, it's the derivative of the area and with respect to time, we need to do the hook for x, which is dx by dt. This one's trickier. So we're going to do the derivative of the area, use our calculator for that, at negative 0.5 times the rate of x, which said in the question that that vertical line is moving at a constant rate of 7 units. I know this one is tricky, but we're going through it. So I'm going to write a of x is equal to this. That's the area. Then I'm going to take the derivative of that at negative 0.5 times 7. And I get negative 9.271, or you can round. All right, what I hope is that A, B, and C, you can do it again, but you should be able to do it. And that part D was a little tricky, and not to be stressed out with the last part. All right, Mr. G Math over and out. Good job getting your work done today.